All right, the quotient rule. So the quotient rule we're just going to talk about a little bit, and then we're going to see how it works on a relatively simple example. But the quotient rule, if you're thinking, oh, not another formula, yeah, another formula, but if you have the formula and you know how to take a derivative, the quotient rule is no big deal. You're just kind of plugging in the ingredients, you're just following a recipe and throwing it in. So the quotient rule, and if you're really kind of clever about this, you can think of the quotient rule as kind of like the product rule, except g of x to the negative first, but we'll just look at it as is right now. So if you divide one function by another, this is most certainly not just as simple as, oh, okay, then it is definitely not just f prime of x divided by g prime of x. I wish it were, but it's not. There are little songs that go along with this. I can't sing, so I won't terrorize y'all, but I always remember this as just the derivative of the function on top multiplied by the bottom minus the derivative of the bottom times the function on top divided by the bottom part squared. Another way to remind yourself of that is low d high. So low would be g of x, d high would be derivative of f, minus high d low, so low d high minus high d low over, oh, there's supposed to be some clever part for the denominator, low squared. That's even worse to remember. So definitely a good candidate for those formula cards. Oh yeah. Yeah, yeah. Oh yeah, he's not bad. Were they helpful at all?
Yeah, no, it's literally exactly what you said.
Okay, yeah. There's some pretty good reviews for that one. There's a ton of calc videos out there though. So we're going to spend a lot more time on this tomorrow, but I think we can knock out this example without too much strain. So 2x plus 1 divided by 4x plus 2. So what we're going to do is we're going to take our top function as that 2x plus 1, and our bottom function is the 4x plus 2. And we're going to need the derivative of each one of these. Unfortunately for us, those derivatives are piece of cake. Derivative of 2x plus 1 is 2, and the derivative of 4x plus 2 is just 4. So we've got f prime g minus g prime f all over g squared. So we don't have to reinvent an entire process or anything. All we're doing is just plugging in. So f prime is 2. G is 4x plus 2. G prime is 4. And f is 2x plus 1. And then in the denominator, that's just regular g squared. It's not its derivative squared, it's just regular g with an exponent attached to it. So that would be an unsimplified form. If we multiply out our numerator here, we actually get a lot of this stuff to cancel out. So we get 8x plus 4 minus 8x minus 4. Yeah, you get 0. Why did we get 0? Because what cancels? Well, why do we get 0 from like the original equation? Are there any giveaways? Yes, that is why it's 0. But looking at the original function, what's that? I like how you're thinking, but I think we're making it a little too much. Is there anything in common with 2x plus 1 and 4x plus 2? There you go. Perfect. So this function, and this is why I like to do this one first, in the denominator, 4x plus 2 is 2 times 2x plus 1. So we used all that heavy lifting just to take the derivative of 1/2. And watch out for those. Love to throw those on an exam because either way, you'll be clever enough to realize that it's just the same thing over something else, or you can demonstrate that you know what the quotient rule is.
But how come whenever we do the quotient rule, we get 0 on the top, right? And whenever we're doing it the other way, we get 1/2?
I didn't do anything to that one. I didn't take its derivative or anything.
Oh, okay.
Yeah, so if you take the derivative of 1/2, you get 0. Yes, sir.
Since you have a common factor, don't you, before you expand it? Since it's 4x plus 2 squared and the 4x plus 2 is on the top as well.
Oh, no, you don't get to cancel those out. We would need to see that 4x plus 2 and everything separated by a plus or minus in the numerator. Dante, did you have a question? Same thing? Yeah. So let me just mention that real quick. Remember, just because we see this same term here and here, I know you'd love to cancel those out, but unless it's over here as well, you don't get to cancel it out. All right, we've got plenty more to talk about tomorrow.
All one equation.
Mm-hmm. You should have plenty of ammunition to get through that skill builder, but you'll definitely have enough tomorrow. But